prefer the heat or the cold? Right now, think of the coldest thing or place you can imagine. Did you think of Antarctica? Or maybe the peak of Mount Everest? Perhaps you even thought of Pluto. And those places are pretty cold, but they are saunas compared to some of the other places out there. For example, take the Boomerang Nebula, which is 5,000 light years away from Earth. It has a temperature of negative 458 degrees Fahrenheit, which is negative 272 degrees Celsius. To put this into perspective, the theoretical lowest temperature possible is negative 273.15 degrees Celsius. This temperature is equivalent to 0 degrees Kelvin, which is where it gets its official name, absolute zero. At this temperature, atoms essentially stop moving. That means that at negative 272 degrees Celsius, the Boomerang Nebula is just barely warmer than absolute zero. But it still isn't the coldest thing in the universe. In order to find that, you're going to have to travel all the way to Boulder, Colorado in the United States. That's right, the coldest object known to humankind exists right here on Earth in a physics lab. Using lasers, a team of researchers cooled an aluminum drum to 360 microkelvin, which is 10,000 times colder than the vacuum of space. The tiny vibrating membrane is 20 micrometers in diameter and 100 nanometers thick. The new technique could theoretically be used to cool objects to absolute zero. But how did scientists accomplish this? To understand that, you first need to know what temperature is. Simply put, temperature is the measure of the motion of atoms. When atoms move rapidly, they create heat, and we perceive that matter as hot. When they are moving slowly, the temperature is considered cold. Remember, even outer space is too warm to cool objects near absolute zero. So, scientists figured out a way to slow the atoms down directly with a laser beam. Now, a laser is light, and common sense says that shining a light on something should heat it up, right? Not necessarily. In this case, the laser is set up so precisely that it actually slows down the motion of atoms by stealing the energy away from the drum as it vibrates. The more organized laser light is, the better it can be at cooling a surface down. Previously, there was thought to be a limit to how far this cooling method could go, because photons hitting an object also have a heating effect. But this new technique takes things one step further. It uses something called squeezed light to get atoms much colder than was previously thought possible. Using this squeezed light, researchers were able to create the coldest object in the universe. Now, the real question is, why do we need such cold materials? Well, colder objects are better suited for several applications. For example, cold objects can make very good sensors. With so little energy, they are incredibly sensitive to fluctuations in their surrounding environment. Such cold materials could also be used in applications like hybrid quantum computers. In fact, by cooling the drum to absolute zero, at which only quantum energy remains, scientists could observe some of the weirder aspects of quantum theory. For now, any application is purely theoretical. But science isn't done solely for application. It is the pursuit of knowledge and understanding. Rumor has it that Faraday himself was asked what value electricity had. Now it has seemingly endless applications. Of course, this is just a rumor and likely didn't happen. But the lesson is the same. Science is done to advance our understanding. If an application is to be found, then it will be found, and will be even better off for having done the research.